Hello dear students, today we are going to discuss the topic that is Newton-Raphson method. So this method is basically used for approximating the root of a particular equation. Okay, since it is a numerical method part, so as I have already mentioned that this is a trick of obtaining the solution or the root of an equation in a very easiest possible way. So this method is also known as sometimes Newton's method or tangent method for approximating the roots of an equation. So we will start very simply. Suppose you are given a condition that is fx equal to 0. This is the equation, and you are being asked to find out the root of this equation. So they are asking you what is the root of the equation. That means you need to find out what is x. That is a simple thing. Now what you will be considering, that you will consider that x naught is the first approximation. So we will consider that this is the first approximation, okay, to the root of fx equal to 0. So when we consider an arbitrary value x naught, it doesn't mean that it is exactly equal to the root. It is not. There may be lots of error. Okay, so this is just an approximation. In the method, the whole process, we will finally see that how close it can be, or and what may be the errors that you may face. Okay, so let me draw a graphical representation of this thing. Okay, so suppose that this is the curve, okay, and this curve is basically representing y equal to fx. Okay, so this is the equation, y equal to fx, and this is the x-axis, this is y-axis. So our problem is fx is equal to 0. That is the equation. Okay, and here y is represented by fx as usual. We have also already done that. Fine. So what happens that first thing we will be considering, since we have considered the approximate root to the equation is given by x naught. So see this, if I consider any point here, okay, arbitrary point, it will be something like x and y, isn't it? So if the approximate root is x naught, so x naught should also lie in the curve. Okay, x naught should also be a point on the curve. So it should be x naught, y naught. Okay, so let this point be. So let, if this is the approximation, then p x naught comma y naught should be on the curve. Okay, should be on the curve. Okay, y equal to fx. Okay, so this thing we can finally, since y equal to fx, so we can also write x naught fx naught, isn't it? We will simply write it x naught f naught. Okay, so to find out the next approximation, because x naught is not a good approximation, we want to suppose that x is a result, isn't it? So now x minus x naught should be actually approximately equal to 0 if it is the correct answer, because now x naught is approximate, so it is not equal to 0. So we want to make it smaller and smaller. Okay, the gap. Fine. So since for the next approximation, so for the approximation to the root, we need to draw a tangent at the point P x naught f naught with an intersection. Okay, we will have to draw the tangent in such a way that it intersects on the x-axis. Okay, intersection on x-axis. Okay, so let us draw that. So let me take a different color. So this is the color done. Okay. So this point is a new point. Okay. So this is x naught. So this is not a new point. This is the only considered point. So this is x naught, and this is y naught. All right. Now the point at which the tangent is cutting. Okay. So that point I will call x1. Okay. So that point will go up to this. You see, if you want to draw this, this is the x1 and this is y1. Okay. So the equation of the tangent for the curve y equal to fx can be written as, so fx can be written as, because we have drawn a tangent now. Okay, we need to write this equation. So that is equal to basically dy dx, isn't it? And that is nothing but f dash x. Okay, but since we have drawn the tangent at this point, so at the point P, x equal to x naught. So obviously we will write it as fx naught. Okay, so this is dy dx. Now dy means it's a difference between two y values. Similar, dx means it's a difference between two dx values. So at the point P, what is the y value? Okay, so y value is nothing but y naught. Y naught is nothing but fx naught. All right. And at this point it is nothing but x. Okay, at this point it is nothing but x naught. At this point it is nothing but y naught, that means fx naught. At this point it will be simply fy. Okay, so we will be writing it as y minus, actually you should write y naught. Okay, but since y naught is nothing but fx naught, I am writing fx naught. And x, dx means difference between x and two x values. So x minus, at the point P, is equal to x naught. So it is f dash x naught. So y minus fx naught equal to f dash x naught to x minus x naught. Okay, then at y equal to 0, if I want to write this equation, from this we have 0 minus fx naught x minus x naught equal to f dash x naught. Okay, because you see, when the tangent is cutting at this point y is equal to 0. Okay, so and x equal to x1, fine. So it is x1. So x1 minus x naught is equal to minus fx naught by f dash x naught. So x1 is equal to x naught minus fx naught by f dash x naught. Okay, so you can understand I will call this point as, so P, this point is called Q. Okay, so this is at Q. Okay, so the point at which this tangent has cut the x-axis, okay, this point gives the next approximation. Okay, so x1 is the next approximation. So at x1 what happens? Y is equal to 0, x equal to x1. So we have just put the values. Okay, so therefore the next approximation for the root is x1 equal to x naught minus fx naught by f dash x naught. Okay, so we can even generalize it. Okay, generalizing, we have xk plus 1 equal to xk minus fxk by f dash xk. Okay, only with the condition that f dash xk is not equal to 0. Okay, so this is a condition for finding the next approximation to root using the Newton-Raphson method. So simply I will tell you I will solve one problem to show you how should we deal with this kind of situation. Suppose that you are given a question that fx equal to x cube minus 5x plus 1. Okay, it is given and you are asked to find out the root of this equation. Okay, find the root. Find root of this equation using Newton-Raphson method. Okay, so again I am going back to the diagram. You see what is the basic theory of Newton-Raphson method is that this is the graph you had. Okay, take any arbitrary point as a first approximation. So the point is represented by the point P. If you draw a tangent and if it cuts in such a way that it cuts the x-axis, so the point at which it cuts the x-axis represents the next approximation. Okay, so this is the first approximation x0, this is the next approximation x1. So that thing you should keep in mind. Okay, so for the next approximation to the root, we need to draw a tangent at the point P with an intersection. Okay, the point at which the tangent intersects on x-axis is the next approximation. So that's simple. Okay, so I would like to show you in a detailed way. Suppose that you have the graph like this, x and y, and the graph goes like this. First y equal to fx. Okay, so first point is this P, so you have drawn like this. Okay, so this point is nothing but x0, y0. Okay, now this cuts at this point Q, so this point is x1, so this is x1, y1. Okay, then at this point, okay, you need to draw another tangent. Okay, so you need to draw another tangent like this. See, now it cuts at this point, so this will again go like this and this is like this. So you can understand that the point is coming closer and closer to x-axis, so it is changing. Okay, So here also we need to solve this thing in that way. So we have this equation, you are being asked to find out the root of this equation by using Newton-Raphson method. Again I am saying that we are not exactly determining the root of the equation, we are just finding some approximation or approximate value. So first thing that you are supposed to do is that suppose we have fx equal to x cube minus 5x plus 1. Okay, now simply you stick to these values, I won't suggest you to go beyond that. Okay, so first you take this value x equal to 0 and x equal to 1. Okay, so first find out fx. F0 means it will be 1, f1 means it is minus 3. So since f0 and f1 is equal to what, 3, means it's a value less than 0. Okay, so since it is less than 0, that means the root can lie within this. Okay, so that means the roots will lie within the range 0 and 1. Okay, so you can call it x0 and this x1. So this is, so fx0, fx1 should be less than 1, sorry, less than 0. Okay, then only this you can find out the root between this particular thing. Again suppose you can try this also. Suppose that fx is equal to x cube minus 5x plus 1. Okay, so let us consider that x0 is equal to say 1 and x1 is equal to 2. So what happens, fx not equal to 1 means 1 minus 5, 1 minus 5 plus 1, so it is minus 3. Okay, and fx1 means 2 cube minus 5 to the 10 plus 1, so 8 plus 1 means 9 minus 10 means minus 1. So if I do fx0 and fx1, it will be minus 3 into minus 1, so it is a positive number. So that means the root will not lie between this range. So root doesn't lie within 1 and 2. So you just abandon this. Then you come to this 0 and 1. As we have already done, it lies between 0 and 1. In this way, you will have to select the range on your own. Nobody can help you. So my suggestion is that start with the simplest one, 0 and 1. That's the thing. Okay, so next find out f dash x. So it is simply f dash x is simply 3x square minus 5. So it is 3x square minus 5. Okay, so we know that alright. So we need to put the values. So xk plus 1 is equal to xk minus, it is xk cube minus 5xk plus 1, and this is 3xk square minus 5. Okay, so we can take LCM here. So 3xk square minus 5, so it is 3x k cube minus 5xk minus xk cube minus plus 5xk minus 1. Okay, so what remains, xk plus 1 is equal to 3 xk square minus 5 So 5xk plus 5xk, 3xk cube minus xk cube. So it is 2xk cube minus 1. Okay. So you see, we are sure that it lies between 0 and 1. Okay. So you are not supposed to start with 0. Okay, don't do that. So you can take some middle value, it's up to you. So you can take say xk means the first approximation. You can take, so I will write, let the first approximation to the root be x not equal to say 0.5. I am just taking the middle point. You can take 0.6 also. Okay, but don't make lot of variations. So x not equal to 0.5. So if you have x1 will be x naught minus fx naught by f dash x naught. So you have that already. What is that? 3xk cube, sorry, 2xk. Here for first approximation k is definitely equal to 0. So 2x naught cube minus 1, 3x naught square x naught square minus 5. Okay. So 2 into 0.5 cube minus 1 divided by 3 into 0.5 square minus 5. Okay. So if you solve this, you will get 176471. So whenever you solve it, you keep a particular number for decimal points. Here I am keeping 1, 2, 3, 4, 5, 6. If somebody wants to keep 4, you throughout the process you keep 4 only. Don't change the decimal number positions. So okay. So this is our x1. Fine. This is the 0.5 is the first approximation, is it? This is the second approximation. So this, no, x2 will be what? x1 minus fx1 by f dash x1. So it means it goes to be 2x1 cube minus 1 by 3x1 square minus 5. Can you understand? In the first step, whatever was done by x0, in the second step it is done by x1. So it will go on like that. So if you put the values, so it will be 2 into 0.176471 cube minus 1 divided by 3 into 0.176471 square minus 5. Okay. So this again gives rise to 0.201568. Okay. So this is the x2. Now you can write down x3. x3 is nothing but x2 minus fx2 by f dash x2. So similarly it will be like 3, as we have already obtained this, x2 cube minus 1 divided by 3 x2 square minus 5. Okay. So if you put all the values, you will get 0.201640. Okay. So you can see that now we are just closing down. Initially it was 0.5, then we got 0.17, then we got 0.2. So if you try the next step, it will be 0.201640. So that means the value is not changing much. It is not at all changing. So you can stop here. Okay. So when it was 0.5, then it was 0.176, then it was 0.201568, then it was 201 640, then it was 201, 640. See, here it stopped changing, so you can just stop here, no need to go further. Okay, so in this way you can solve equations by finding approximation to the roots of the equation using Newton's Raphson method. Thank you.